Hey, hope everybody's having a good, what is it, Monday, Tuesday, Wednesday? Yeah, we're up on Tuesday and got clear skies here, but you've probably noticed things look a little bit hazy outside. So some of that dust has made its way up from the Gulf of Mexico after making a long trip from Africa. It's hard to believe we get the Sahara sands all the way out here, but it is a significant source of particles. Okay, I just loaded up some data, so let's head to that chart and see what's going on across the U.S. And there we go. I guess we'll start with the northwest United States. We know that yesterday there was a frontal boundary kind of moving eastward through that area, and cool air coming back in from behind. So we're going to be looking for a boundary up there in the Idaho, Montana area. And then we'll shift down to the desert southwest. What do we got here? Only 98 degrees, only 105 at Blythe. So much cooler out in the desert southwest. So probably the upper level high starting to back away from that area. I've really got the crowding cranked up. I'm going to have to kind of lower that a little bit. Okay, so let's replot that, and we see that we've got high pressure across the northeastern U.S. So very cool conditions, only 70 degrees in West Virginia, and in the 60s way up there off the top of the screen in Pennsylvania. So that's a little bit of a source of a backdoor front pushing southward, and it looks like the southern part of the boundary, maybe all the way to northern Alabama, Atlanta, maybe in Arkansas, somewhere in this area. Okay, so we'll keep an eye on that. And also in the northern plains, looks like we have another frontal system pushing south, and there it is right there. Okay, we were going to talk a little bit about tropical weather. I want to start gearing things up for hurricane season, because for all we know, like about a month from now, we may be looking at another Ike or Katrina. So it's probably good to get up to speed on everything here. And I think a good place to start with the tropical segment is with the polar orbiter data. Now, of course, the big thing that you notice, South Florida, or South America down here in the lower left. In the upper right, we've got Africa. And you'll notice in between, we've got this band. Okay, so you've probably seen this on past weathercasts. That is the intertropical convergence zone in terms of around the equator. That's known as the, I guess we can call it the tropical rain belt. It's also known as the doldrums. And where this comes from, well, we have to look at the heat balance in the atmosphere. I've got a couple of interesting graphics here to look at. We'll start with this one here. This shows the net radiation derived from satellite imagery here. So basically what we're seeing here, where it's yellow along that blue line, that indicates where there's about as much energy going into the atmosphere as there is coming back out. North of that, there's a net loss. So the atmosphere is losing heat. But here in the center, obviously we're getting a lot more input than what comes out of that area. So you can see that the heaviest intensity of that radiation pretty much centered from the area around Thailand, Vietnam, all the way to south of India, and then across the Sahel and north of South America. And what this does is this forms up a low pressure area in the equatorial regions. We get this whole area becoming buoyant, very strongly heated, and it rises and spreads. And consequently, when we're removing air like that in the upper troposphere So you see here we're removing air. There's going to be a net inflow in the lower levels. So what that does is that forms up the trade winds. So they're going to look something like that. And I can actually give you an example. This is a chart from today. This is from NHC. Here's the legend. And I think that's actually from last night, but that works just the same. And that shows you that intertropical zone stretching from that area just off the West African coast to northern South America right there. And you can see where it says ITCZ. So converging into that ITCZ, the trade winds, and of course when they cross the equator, the Coriolis force diminishes and reverses signs, so we get a little bit of a bend like that. So right there, this is basically the equatorial rain belt. So we got flow coming into it from the low levels and departing it from the upper levels, helping to ventilate that area. Now, embedded in the tropical circulation, not within the intertropical convergence zone, but either side of it, we've got easterly waves. And these tend to be embedded in the Bermuda High, like what you see up here. And here's a very good example of a easterly wave. This is another one here, and we can probably find more looking at this data. So yeah, here's a very good example. That's probably an easterly wave trough right there. And in between we can have easterly wave ridges where we get some very fair weather. So probably getting some of that over Dominica right now. I did see a little bit of sad news when I was looking at these charts. I was trying to find the actual surface chart itself. Some of those you're familiar with DIFAX, you probably remember these. I think they have shut these down as of last week. So you can see the time on this, July 19th, and I can't find any newer ones on the internet. So I think this is another product that's bitten the dust. And that's such a shame because we've got such a high density of data. Here we've got satellite-derived winds. We've got the synoptic plots. And this is just excellent data to have. I mean, if we go up to the north, let me see if there's a way I can unshrink that. I guess I can't. But anyway, this is another good chart for helping to find easterly waves. Well, digital atmosphere is around, and that will help you to a certain extent. But you can see that this is the trade wind belt right through here in the Caribbean, and you can see the isobars. That's these lines I've outlined in blue. So a strong pressure gradient across that. Up to the north, you've got the Bermuda High, and to the south, you have the intertropical convergence zone. And this is a graphic from an old WeatherWise article. This kind of helps you visualize things. I drew up this chart about several years ago. And this is showing a phase where the ITCZ is north of the equator. So this is going to be like in July, like about right now. And you can see the rain belt there on the north side of the equator. And along that rain belt, we get upward vertical motion, and you can see the flow of air out from that. And as it flows to more northerly latitudes, we get subsidence, and that helps form the subtropical high. And that's a big reason why in the subtropical latitudes we find deserts. Saudi Arabia, Africa, and of course Australia, which is probably about half desert right there, especially in the western part of the country. And even in Africa, you've got the Kalahari Desert right there. And if you ever get a chance, go into Google Earth and look on Panoramio and check out this coastline. This is the Skeleton Coast. And I think it's named that because of a bunch of shipwrecks from the old trading days. But inland, some very beautiful terrain in Namibia and Angola. South America almost exempt from that subtropical desert, but not quite. We've got the, I think it's the Atacama Desert right there at Chile. And of course in the U.S. we've got our own Mojave and Chihuahua and Sonora deserts. And there they are. Okay, so that's probably about all I want to cover for this installation of the tropical lessons, and they're going to get a little bit more complicated as we go through the upcoming week and into August. So I really want to start getting into some heavy coverage of hurricane dynamics and that kind of thing. But of course we have to start with the basics here, so now you know a little bit more about the intertropical convergence zone. And I need to reiterate that this ITCZ is mostly an oceanic feature. Do you see it here? No, not really. It's because it's broken up by friction, by outflow boundaries, by surface heating, by monsoon flow. And it's getting to be about monsoon season in India, and there it's kind of broken up, including over Indochina. So the ITCZ is mostly an oceanic feature, but if we want to refer to the continuation across the continental areas, we can pretty much consider this the tropical rain belt. That's probably a better term for that. Okay, give me just a second here, and then we'll start going down the list of chat. And give me just a second. Okay, I'm starting to lose my voice there. Let's see, we've got Lexi and Joshua. Is the live stream recording not available? Yes, it is. It does take about half an hour for it to post. We've got EIS Fan 51 and Joshua Gilbert. Also Alexi. And I just had a whole bunch of more chat appear right before my eyes. Andrew, Mike, and David, Mega John, Justin Pulliam, Kevin McKinney, Alexi, and Burl H. And I think before I get much further, I want to... I've got a little bit of nasal congestion. I want to try to fix that. But before I do that, I want to set you up with a little bit of video. Okay, so I'm going to show you a little bit of time lapse from previous days. So this will take just a minute, and then we can go back and continue the broadcast. Okay, so be back momentarily. Okay, much better. This is a little bit of video from April 25th showing tropical flow that was coming up from the Gulf. Alright, so much better. So let's continue. So there's our intertropical convergence zone stretching from Africa to the north coast of South America. Now, one other interesting thing I wanted to show you, and you get a little bit of a freebie here because this is kind of an obscure link. This is an article I wrote for WeatherWise on the intertropical convergence zone from 2009, and this is the link to it. And this will kind of teach you everything you want to know about that. And here's a short version, so you can copy this link down. It's bit.ly/2t big X big V small j small t small n. So that's bit.ly/2t big X big V little j little t little n. And if you missed that, you can just watch the replay. And that's got the article right there on the intertropical convergence zone. And I talked to a couple of ITCZ experts because there's been a lot of debate about what exactly the definition of the ITCZ is. You can measure it by pressure, wind speed, cloudiness, and which one is correct. And I talked to a couple of people, and you can read up on that and kind of get the information right there. But basically the definition of the ITCZ is basically where the trade winds come together, and it's not necessarily defined where the precip and clouds are. Now, if we consider the tropical rain belt, here's one thing that's really interesting. Okay, I've probably got a better version of that. Let me pull this up here real quick. This is the directories where I do all my WeatherWise writing. So let me check here real quick. ITCZ. Okay, it's probably a special feature here. Well, dang, I guess I can't find it. Anyway, let me just show you this real quick. It's probably no big deal if I just kind of go through this real quick. But you'll notice that the February position, where the ITCZ is very far south, it's south of the equator during the northern hemispheric winter, and the equator is right there. But you'll notice that part of it extends north of the equator in the winter. And there's not a whole lot of understanding about why that's the case. It's got, obviously, it tends to impact Venezuela and northern South America quite a bit. And then during this time of the season, we see it come up into the Caribbean and as far north as Sudan, where they get the big haboobs, and into India, where they get much welcome monsoon rain. And are they getting that monsoon rain? Let's take a look. Almost looks like it's making some headway northward, but it is not quite up to the northern parts of the country right here. So here, big drought, very hot temperatures. And for them, it's usually a waiting game. The weeks leading up to the monsoon are just about unbearable because of the very high humidity there. And when the monsoon starts arriving, these cloud areas start moving further and further north, and they finally get relief. And these people, obviously, well into the monsoon pattern there. And by monsoon, we're talking about the very intense heating in the desert interior here. So there's a bit of inflow coming into the continental regions, and that's very similar to what we have in the desert Southwest. We get very strong heating in June and July, and we start bringing in tropical air coming from the south. So very similar, and it's not necessarily the same thing as the ITCZ. Okay, let's see here. Actually, I've screwed this up. I brought up some imagery that was a little bit old. Okay, there we go. So there's the southern U.S., and you can see lots of boundaries down there along the Gulf Coast. And let's look at the big picture. This is South Dakota. They've got thunderstorms all the way up there. And this is the GO-16 imagery, 5-minute image showing very cool overshooting tops. Further south, there's the monsoon pattern across the Four Corners area right there. Not much going on in Texas. But however, you can see a little bit of anticyclonic flow. So this is the upper level high. So you see that bit of rotation right there. So upper level high established over the Lubbock area down to Midland. So we're going to be probably finding some very hot weather in that part of Texas. Okay, let's see. I'm trying to figure out where to go next. Let's look at the fronts. Okay, yesterday we were looking at a front making progress into Oregon and Idaho and Montana. Looks like today it's kind of become quasi-stationary through Northern California, maybe up to Montana, and maybe another piece of it up through the Dakotas. So probably something like that right there. Then looks like another, let's see, I'm not too sure where the warm front is, maybe through Iowa. The warm front extending south, maybe something like that. And then what we have up in Canada, this is probably an occluded low up near Hudson Bay. And down to the south we can see where some boundaries have been stacking up in the southeastern U.S. and driven by that northeastern high. And there's that flow coming out of the north across Virginia, the Carolinas, Tennessee, and Kentucky. So what kind of pattern do we have in Texas? Well, we've got dust, and one way we can look at the dust is to pull up the aerosol optical depth. And there it is. Let me bring up the coastlines and the state lines. And there's Texas right there. And you can see the dust there along and east of I-35. And it's also made some progress into Mississippi and Alabama, and given us that hazy sky that we see right there. Okay, let's look at soundings and check out Fort Worth. Starting close to home here, we see that there's a little bit of moisture near the ground, lowest 1,000 feet, but dry air just off the surface. There's the 15 Celsius line. So when you go left of that line with the moisture, you're getting into dew points in the 50s, which is not good if you bring that air to the ground and start mixing it up. You start lowering the dew point, and then it gets very hard to ascend through this warmer low-level air. So if we mix the parcels up, we're going to come up with something like that for moisture. High temperature of 88 maybe, so we're going to go like this. And it looks like we're almost warm enough for maybe some convection and maybe some long skinny cape. A little bit of convective inhibition. And that's not very much convective inhibition, so I think it has been reinforced during the day. This sounding is for this morning. Okay, elsewhere, let's look around the country. Let's look at Wilmington, Ohio. I know there's a few people in that area, and we see lots of dry air just off the surface. I mean, wow, that's a lot of dry air there. And can we see it on the water vapor imagery? Well, let's see, where's the water vapor imagery? Yeah, a little bit. Looks like it's been reinforced with a little bit of moisture. But that sounding that we looked at was for this morning when we had drier air, and I think the dry air has shifted southward and is now over Kentucky and Tennessee. So if we bring up soundings now for maybe not Nashville, but maybe Virginia, we should see some dry air there. So let me change the time. We'll look at tonight's soundings. Then we'll pull up Sterling, Virginia. No sounding available. We'll try Roanoke, Virginia. And there's the dry air just off the surface. Elsewhere around the country, let's take a look at Omaha, if they're available. No data. So then we'll just try Davenport, and nothing there. So we're a little bit too close to the 0Z hour to look at soundings. So this is probably a good time to continue to the forecasts. And before we get into that, we'll look at the dynamics. Trying to get this to stay. Okay. Okay. Even if I'm on the other monitor and I move the mouse, it wants to move around. Okay, so anyway, so I'm not going to worry too much about that. But let me take a look at the chat. 105 degree dew point or heat index where Ryan is. Alexi says that's refreshing. Burl H joining us. Ryan Toomey is seeing a little bit of buffering, and I did have a Steam download going, I found out yesterday, and I shut all that down before we went on today. Ron Chalfant saying thunderstorms in Las Vegas today with flash flooding. Brian Harp made it in this evening. And Ryan mentioning something about water temperatures, NHC buoy ocean readings. Justin Polium asks, is there a standardized map projection for weather charts? No, not really. It depends on where you are exactly. In the tropics, you're going to use Mercator. And at these northerly latitudes, like you see right here, this is going to be stereographic or Lambert. Ryan says a full railway train effect of easterly waves. And let me bring up that data again. I think earlier when we started the webcast, we were looking at some old data out in the Atlantic. So let's bring this up. And yeah, this is for July 25th. Okay, so there's the intertropical convergence zone. And then these latitudes that you see up here, this is basically the trade wind belt. And as you go further north, you start getting under an inversion. There's kind of like a marine layer. So at places like Cape Verde, there tends to be a lot of fog and stratus, and the worst airplane disaster that ever occurred, 1977. That was in Cape Verde, and that was due to fog at a higher elevation airport in this area here. That was the Tenerife disaster. Mike Estwick says, you're right, Difax is gone. Yeah, that's depressing. Hiker AZ says, Tucson has received half of its average monsoon rainfall in 2 weeks. Okay. Sometimes when I'm sitting here reading the chat, I'll be going through these messages and I'll get to the very end, and then YouTube will push another 50 messages, so I can't really tell when it ever ends. Yeah, I'd gotten to this point, and there's a lot of discussion, and I'm probably not going to be able to get to all of this. There's a lot of chat in here. But let me just scan this real quick. Tsunami in Pacific and tidal waves in Atlantic. No, it's going to be tsunami on either side. I think maybe the confusion there is typhoons for tropical cyclones in the western Pacific, and then hurricanes for tropical cyclones in the Atlantic. As far as ocean wave disturbances, they're tsunami all over the world. Why can't they just name all hurricanes? Yeah, that's just how it is. Haiti in 2010, hit by a tsunami after the earthquake. A little discussion about Fukushima, and Ryan is concerned with this fall. Way too much complacency going on with hurricane preps. I'm not sure. Okay, time to head into the forecast. Let's do that, and we'll start wrapping up here. The high-resolution rapid refresh, which is our mesoscale forecast, showing an MCS developing from Minnesota into southern South Dakota. So overnight, that's going to move eastward almost, pretty much to Minneapolis, St. Paul, probably rolling in about 3 or 4 in the morning. Also storms coming into Omaha. And looks like the MCS dies off after dawn in Wisconsin and central Iowa. So that's going to be most of the action overnight. Minnesota back into the Dakotas. And then let's look at the synoptic scale picture. For tomorrow, for Wednesday, there comes our next frontal system. Looks like it's oriented something like that, so good probability for showers and storms in Iowa. Then for Thursday's webcast, Thursday coming up pretty quick. Looks like we've got a warm front in Ohio, Indiana, and a cold front extending southward into Oklahoma City and Dallas. GFS not going for much in the way of shower activity, so I think maybe most of the moisture is heading up to Mississippi like that. Very weak Bermuda high. That's the other problem. Not bringing much moisture north. Then for Friday, things are dominated by this Great Lakes high. So that's going to push that frontal system on into Tennessee, Kentucky, and southward into the Red River. Good chance of precip in Ohio, West Virginia, and Pennsylvania. Again, this is on Friday. Then for the weekend, frontal system pretty much clears the East Coast. Tail end comes into the Carolinas and Georgia and into East Texas. So maybe a little bit of a chance for precip in Texas and Louisiana there. There's the big Great Lakes high. So it looks pretty cool and mild for that part of the country. Okay, then for Sunday, continued Great Lakes high. There's the tail end of that front, pretty much right down to the Gulf Coast. And you can see that we've pretty much gotten rid of a lot of the thunderstorms in the southern U.S., and that's because we've brought dry air southward. August 1st, Tuesday, boundaries start coming back up northward a little bit as the large-scale flow comes up out of the south, and it looks like we've got a new frontal system in Colorado. There it is right there. So we'll watch that next week, about a week from now. That looks to be pretty potent. So that'll affect Kansas, probably a chance of severe there around Salina, Topeka, Emporia, maybe up to Des Moines and Omaha. That's around August 2nd. Then for August 3rd, there goes the frontal system. You can see the dry air coming back in behind that, and you can also see the comet cloud shape right there. Kind of an unusual frontal system moving through the central U.S. And then for the 4th and 5th, that'll carry that into the northeastern U.S. Looks pretty quiet for the central U.S., boundaries pushing all the way to the Gulf Coast. Maybe a little bit of upslope storms in the Big Bend and West Texas. And then we start getting to the end of the chart sequence. GFS bringing a tropical cyclone up into the Carolinas. And things once again active in the Pacific Northwest. Look at that strong frontal system right there. Lots of thickness lines up there in the northwest U.S. And fall is going to be rolling around here in about 4 to 5 weeks. So we're getting into the tail end of summer here. Okay, I think that's about all I got here. It looks like at the very end, maybe a little tropical disturbance in the Gulf. This is around August 10th. And then after that, the week after that, we're going to be looking for the eclipse coming up. And that's going to affect pretty much everywhere from Oregon all the way down to the Carolinas, pretty much along that route right there. Ryan says water temperatures are high in the Caribbean and Atlantic right now, so I guess we're going to have to start watching out for tropical development. Ryan says watch the Atlantic Ocean change going into the second week of August. And one thing that we got to keep in mind, the peak ocean temperatures, that's going to be around September 9th. So the water temperatures are still gradually coming up. And we haven't even started tropical season yet. So we're going to keep doing these little lessons on tropical storms, tropical cyclones, and all that. And we'll continue the next installment tomorrow. So I think that's going to do it for today. I thank you for joining, and hopefully we'll see you tomorrow. Take care.